this. So I'm going to start by asking you how many seconds are in 2 minutes. You may have right off the top of your head say that's 120 seconds. But how did you get there mathematically? Well, you multiplied by 1 second, you multiplied by 60 seconds is in 1 minute. Okay, so 2 minutes has to be 120. How are we going to use dimensional analysis to solve this? Well, there is a true statement that 1 minute equals 60 seconds. Okay? Now I can turn an equivalent statement is a true statement, and this can be turned into a conversion factor. And that is what we use to multiply and convert units. So I can say that in 1 minute there are 60 seconds. I can also say another true statement is that in 60 seconds is 1 minute. Okay? So you can see these convert. Okay? So let's look at how we use the conversion factor to do this. Now I know many of you can do these in your head, but you're being tested on dimensional analysis. So make sure you understand it. You'll have to show me your work for credit, and we'll have to be using dimensional analysis because this is the lesson. We're going to be using this throughout chemistry to solve many math problems, and although this may seem easy in your head, other ones won't, and if you don't know how to do So let's take our problem. We write down our given. We were given 2 minutes from this question, okay? And now, whoop, whoop, whoop. That is a conversion. I don't want minutes anymore, so I'm going to take that unit and put it on the bottom, and I want to go to seconds. And now, this is my conversion factor. This is a true statement. Here it is down here. Remember, this can Okay, we need to use 1 second is, or excuse me, 60 seconds is 1 minute. Okay, now we're doing this like a fraction. Okay, our units cancel out. Why do they cancel out? Well, let's look at algebra up here in this corner. Over A, and I'm doing variables. These variables right here cancel out, and I'm left with B. Units work the same way. If I have a unit in the numerator and a unit in the denominator, they'll cancel out. I'm left with 60 seconds. I multiply by the top, and I divide by the bottom. 2 times 60 divided by 1 equals analysis works. Now let's use that same conversion factor, but we're going in a different direction. Now here's my given. My given's 120 seconds. I always write down my given, okay? And whoop, whoop, whoop. Let's convert seconds. How do I get rid of it? I put it on the bottom, and then I'm going to minutes on top. I need to put in my true statement. My true statement is 1 minute is 60 seconds. I multiply by what's on top. I divide by what's on the bottom. 120 times 1 is 120. That's going to equal 2. And how do I know what units to use? Seconds cancel out. I'm left with minutes, so that's 2 minutes. Yes, I know you guys can do this in your head, but when I show you something that you already know how to do, sometimes it's easier to understand the problem. Convert metric units, okay? So here is our metric unit conversions. and I want to explain how this chart works. First of all, let's look at our base. Our base is at ground zero, and down we have names for these prefixes. Kilo is worth 1,000, hectos 100, decas 10. Our base is where we start, and then deci is 0.1, centi is 0.01, millis 0.001, and then we jump down and we have micro and nano. How can you KISS daily because divorced costs money. Okay, I like that one better than the Good King Henry one. So that can help you remember it. However, you, for your homework, are going to make this chart right here. You're going to recreate that by hand, and then you're going to upload it, and that's going to be worth 5. This you're going to be using on many, many tests throughout chemistry, so make sure you always have this handy. So here are abbreviations. Kilo is with a capital K, hectos with an H, decis a D, centis a C, millis an M, micro new, I believe, and nano is N. Okay, so what do these mean? Well, first of all, these are prefixes, and they can be used when we're measuring distance. If it's distance, we're going to use meters, so then we're talking about a kilometer. If we're measuring lab, and we use liters, so we can talk about a kiloliter. If we do mass, we're talking about grams, and then we could have kilograms, okay? So these prefixes are interchangeable based on our measurements. 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. 1 kilogram equals 1,000 grams. Now, right here I have all three bases used with the kilo, and that those are interchangeable. This is our equivalent statement, just like 1 minute is 60 seconds, 1 kilometer is 1,000 meters, which means I can make a conversion factor with that, okay? I can also flip that conversion factor converting to kilometers. How do I know that? Well, we have our template for our conversions, and our template is we write down our given number, okay, with our units. Whoop, whoop, whoop. Get rid of the units we have by putting it on the bottom, putting that on top. Make sure you know this template. Make sure you have it in front of you for all tests. When you get lost on conversions, check it out. We multiply by what's on top, we hit equals, and then we divide by what's on the bottom. Okay? So, we have many that I want to talk about is centi. Okay? A centi 0.1 meter. Now, many of you may remember that there are 100 centimeters in 1 meter. That is also true. These are both equivalent statements, and you can make your conversion factor with the 0.01 gram per centigram, 0.01 meter per centimeter, You can also say that there are 100 centimeters in a meter. It will help to make sure you know what goes with what. Some people like to say there's 100 meters in 1 centimeter, 100 meters in 1 centimeter, but that's not true. Think about your meter stick. Do I have 100 of those meter sticks for one tiny little centimeter? meter stick. So when you think about that meter stick, sometimes this will trigger your memory to make sure that you put the 100 with the correct thing. 100's always with centimeters and 1 is always with meters. Okay? So now let's use this chart to do some conversions. This is what we're doing. We're taking this information and figuring out how to convert kilo. If I have 1 kilogram, how many grams do I have? Well, in our head, 1 kilogram is 1,000 grams. That is our true statement. But let's see what happens if we have bigger or smaller numbers. Okay? So convert 10 grams to kilograms. Using this template, I'm going to write down my given number. I have 10 grams. Whoop, whoop, whoop. Do I want grams anymore? I do not. I want to get rid of grams. How do I get rid of it? I put it on the bottom, and I am going to kilograms. Okay? Now, what is our true statement? I have in every kilo, I have 1,000 of my base units. Okay? We're doing grams. So in every 1 kilogram, I have 1,000 grams. So in every 1 grams, okay, so we're going to be multiplying by that and dividing by that. So pop that in your calculator, hit pause, and make sure we have the same answer. So here's my calculator. Do I have to multiply it by 1? Not really, because it's going to stay the same. Okay, and then divide it by 1,000. And I get 0.01. Now what are my units? Well, I was converting to kilograms, but you can check by crossing out your units. This is the best part about dimensional. I know I set it up right because I was going from grams, it shouldn't be there anymore, and I'm going to kilograms. Okay? So now here's our next problem. Convert 5 microliters to liters. I write down my given, 5 microliters, and now it's a conversion. Whoop, whoop, whoop. I get 2 liters. So now, if I look over here, which one do I use? How do I know which one I use? Well, I know that 1 times 10 to the 6th goes with my liters, and 1 goes with my microliters, whether it's on top or bottom. So 1 goes with microliters, and 1 times 10 goes with liters, okay? So I have 5 times 10 to the negative 6th liters. My microliters are gone. I'm left with liters. Let me show you how to put that in your calculator. All clear. So I have 5. And when you hit exponent, that means times 10 to the negative 6. Now, many of you have different calculators. You might have to put 6 negative. You also might not have an EXP down here. It might say times 10. Or some of you might have an EE button here. That would be second function EE. And that means, okay, and there's my answer. This is the problem people have. They want to use carets times 10 and then something else. Don't do that. You have to use EXP or EE, or if a times 10 is down at this bottom. Don't use this times 10 here. That is part of the logarithmic scale, and that won't work on your calculator. Okay? So I'm going to do one more from your worksheet that will be due Tuesday when we get back to school. We're converting 4 centimeters to meters. I'm using my same template for conversions. I'm writing down my given number. And then I have to make my conversions. Whoop, whoop, whoop. Do I want centimeters? I do not want centimeters anymore. How do I get rid of them? I put them on the bottom so they cancel out, and I want to go to meters. Now I need to find my true statement right here, and I like using the whole number here. If you like using the 0.1, that's fine, but notice the 100 goes with centimeters, 1 goes with meters, okay? So make sure that is correct. There's something wrong with this guy. You will have a corrected version. There, I'll fix that. Okay, so I have in every 1 meter, I have 100 centimeters. Okay, so multiply by that, divide by the bottom, put it in your calculator, see what you have. Okay, so divided by 100 equals 0.04. Okay, now we need to look at your significant figures. We multiplied and divided. And this is what you need to know for your homework. I have 1, 2 significant figures in my given. Any conversion factors never count in significant figures. So basically, when you look at these problems, whatever your given number is the same amount of sig figs we should have here. Okay, now I underline this. And it's naked, so I need to give it close. 0.040 meters with the correct number of significant figures. We didn't talk about that when we took our notes. I didn't want to confuse you, but now I've added it in, so make sure that you have the correct number of significant figures. That will be part of your score when you take a test or quiz. For this worksheet, if you can't print this out and take a picture and upload it, and show me your work, but in order to have credit, I need to see your work. It needs to be set up with dimensional analysis. It doesn't matter that you know how to move your decimal over. That's not what you're being tested on, okay? This is dimensional analysis practice. So make sure